Oh, it's recording. Okay. Okay, so I was thinking we start with the three new examples I just made up and gave you guys in class, because you guys don't have an answer key or anything for those. And also, please keep in mind that since I did just like seriously make them up, we might get numbers that are not nice, okay? But that's okay. It's a process that we are practicing. Okay. And then depending on how much time we have left, then I think we'll go back to the original exam one review. So, in 2008, 25% of pet owners believed that vets charge an unreasonable amount for their services. In 2015, a survey conducted by Gallup reported that 400 pet owners believe vets charge an unreasonable amount for their services from a random sample of 5,000 pet owners. In the following steps, test the following claim. At a 5% level of significance, the population proportion of pet owners in 2015 who believe vets charge an unreasonable amount for their services is less than 25%. For all these parts, we are going to round to 3 decimal places if needed. Maybe we aren't doing any decimals, maybe it's less than 3 decimal places, but if needed, go to 3. So part A. There we go. Okay, so part A, state the null hypothesis, alternative hypothesis, and state what type of test this is, okay? So recall on the exam, I am okay with you either writing out the words null hypothesis, alternative hypothesis, or using just the symbols we use for them, the H sub naught and the H sub A. Or use both if you want to, you know, you just want to be extra careful. So I'll go ahead and just write out both. So the null hypothesis, or you could have used H sub naught, right, is given, blah, 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 is P equals 0.25. So that's what we're starting off with our null hypothesis. That way then for our alternative hypothesis, which we denote as H sub A, that we get from our claim. It's the last sentence of that paragraph above. It says, believe vets are charged an unreasonable amount for their services is less than 25%. So we want to test the claim that the population proportion is less than 0.25. Lastly, what type of test is this? When we say that, what type of test it is, I'm referring to left-tailed, right-tailed, or two-tailed. So which is this? Left-tailed. Left-tailed. Good. Okay. Let's continue. Part B. Calculate the sample proportion. So the sample proportion we denote as P hat. And in case you draw a blank, I am going to be constantly referencing the formula sheet, okay? So in case you draw a blank on how to find the sample proportion, it is given on the formula sheet. Under the unit 6, it says sample proportion equals P hat, which is successes over N. Which in this case, what are we considering a success? It's just those who said yes to what we're considering here, which is that pet owners believe vets charge an unreasonable amount for their services. So when Gallup did the survey in 2015, they said 400 people believe vets charge too much, right? 400 people out of how many people were included in that survey? 5,000. From there, it's a calculator. I did this super fast when I did it, so I'm just going to double check it in my own calculator. So 400 divided by 5,000, that'll be 0.08. Everyone good so far? Any questions? Okay. Part C, calculate the standard error. So again, referencing the formula sheet under Unit 6, look down to where the hypotheses testing is, and about 1, 2, 3, the third one down from there says standard error. That's literally the one we're using. Standard error. which is given to be sigma sub p hat, which equals the square root of p times 1 minus p all over n. So please be careful here. Probably the most common mistake I see is that students, instead of using p, they use p hat. Okay, so remember to use p here. For a one hypothesis testing from the formula sheet, it is telling us to use p.
So I have a question. It almost seems too simple, but throughout all of the work we've been doing, it's like I inherently knew which one was p hat and which one was not. And now that we're here, I'm like, oh my god, which one's which? What is like a certain way to know? Is it that p hat we always have to do the math of?
The p hat may also have been given. It could have been, you could have been told that the Gallup survey conducted a survey and they found, 46% of people found that they thought that vet services charged too much, right? But it's just like they're doing this new study. It's the newest study from a new random sample. That will be your p hat.
And it will always be like the initial.
P is always the initial, and in this case, for these single hypotheses, p will always equal the number that you denoted here. Since we said p equals 0.25, we're using that same p here.
Okay, that makes sense.
So, any other questions? All right, so let's plug in that 0.25 in for p. That's 1 minus 0.25 all over n. N was the sample size of 5,000. I had gotten 0.006.
Yes.
Okay, cool. Part D, calculate the z-test statistic, or just the z-score, which again, you have the formula for on your formula sheet. Just make sure you're comfortable identifying it. So z equals p hat minus p all over sigma sub p hat. Remember, you also had the other option of how to start it off as. You could have also done z equals p hat minus mu sub p hat all over the standard error. They're the same thing, because remember that p is equivalent to mu sub p hat. They are literally equal. Okay, by definition, they're equal to each other. So it's up to you which format of the formula you prefer. Personally, I just prefer the top one, so I'm just going to continue from there. You get the same answer regardless. So p hat, we already said earlier, p hat was 0.08 minus p. P we also found earlier. We had defined p to be 0.25 all over the standard error, and the standard error we just found in part C. That's that 0.006. So you're just plugging in the information you got from the previous parts. So 0.08 minus 0.25 divided by 0.006. And again, we get an ugly number because I had just made up these numbers. I had no idea how they were going to turn out. So I'm so sorry that the z-score is an ugly negative 28.333. All right. But I remember there was a lot of people who were like, what? We haven't got anything this big. Yeah, it's not
Usually
normal.
I was doing it wrong if I
Yeah.
had something like that. So I was like,
So this is just an example of emphasizing the, hey, just be confident in your process, right? Be confident in the steps. Be confident in your process. And this is the z-score that we should be getting. Okay, part E. Find the p-value. All right, p-value. And it again, on the formula sheet, it's even telling you what to do. It's telling you to use the normal CDF, right? So p-value equals the normal CDF. And actually, you know what? Before I write that, let me write it out in the probability notation first, which I'm not requiring, but I still like to have it. I know it's helpful for some people. I'm going to write it in purple. But finding the p-value, what we're really doing is we're finding the probability that z is less than this z-score. Okay, we're finding the probability that z is less than this z-score. Why less than? Because that's what we said from the start. Left-tailed, and we had also said less than here. So less than negative 28.333. All right.
Professor,
Yes.
is that going to be required for us to do that on the exam?
No.
Okay.
But what is required is the normal CDF. I do want you to write out how you are entering into your calculator the normal CDF. So I do want you to do normal CDF, parentheses, the lower bound, negative 9999, upper bound, negative 28.333, followed by 0 and 1.
Parentheses part, so I'm glad you said that.
Okay, yeah, I want to see that full thing as I have written here in blue.
Just p-value equals normal CDF.
And then and then enter in, and also write what the lower bound, upper bound, mean, and standard error.
So you want the formula as well, what you wrote in purple?
This is optional here. This is optional, but I want p-value equals normal CDF. And then, of course, to write out what that then actually equals, right? So as many of you already know, this gave us 0, right? Again, that wasn't my intention. What is this in percent form? 0%, right? Not meant to be a trick question. Just it's still 0.
Even if we have the 83, you want us to do the 0 and 1?
I would like to, yeah. 'Cause that shows to me that you recognize that for z-score, you know that the mean and standard error are automatically 0 and 1. Because that's not the case if it's not a z-score. Part F. Do we reject or fail to reject? Remember, where you see fail to reject, that's the same thing as saying do not reject, right? So do we reject or do not reject? Same thing, whichever phrasing you prefer. So do we reject or do not reject the null hypothesis? Do we support or not support the alternative hypothesis? Why? I personally like to start off with the reason why, which is we look at our p-value and compare it to your level of significance, right? So our p-value, which is 0%. What was our level of significance? 5, thank you, 5%. Is less than or equal to 5%. That's our level of significance. So this is statistically significant or is not statistically significant? Is statistically significant. Is statistically significant.
Can you explain why it is so big?
So anytime, I'll do it up over here. Anytime your p-value is less than or equal to your level of significance, then we say it's statistically significant. Statistically significant. If your p-value is not less than or equal to your level of significance, okay, if it's not less than or equal to that, then we say it's not statistically significant. Statistically significant. Okay. So, since it is statistically significant, do we reject or not reject the null? Reject the null. And since it's statistically significant, do we support or not support the alternative? Support the alternative. Good. Alternative hypotheses. Okay, cool. So we know in general what to do with our null and our alternative to support or not support, reject or not reject. And now, since we know that, we're going to take it and put it into actual conclusion in the context of the problem. And very much at this point in time, even I myself need to go back to the original paragraph, go back to the original problem, be like, what the hell was our claim? I forgot, right? Like it was so long ago. So I'm just going to highlight it. So what was the claim? Blah, blah, blah. Oh, the following claim, 5% in the significance level, the population proportion, blah, 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 blah. Okay, and we said that we're in support of it.
Mm-hmm.
So combine the two, saying that we support and then that claim. So I'm going to say at the 5% significance level, the sample data support the claim that, and then you could even copy it word for word from here. Support the claim that the population proportion of pet owners in 2015, the population proportion of pet owners in 2015 who believe vets charge an unreasonable amount for their services, who believe vets charge an unreasonable amount for their services is less than 25%.
We put that, but without the 5% or the words population proportion, would it still be correct?
I want the significance level, and I want population proportion because that itself is stated within the claim here.
I just put data supports the claim that in 2015, less than 25%.
I did
blah,
the
blah,
same
blah.
thing.
Yeah.
add-
So if you want to be careful, like, don't even just
Change it
copy
out.
it. Yeah, just word for word. Because the
I put-
claim is listed here for us.
Population, but not the word proportion.
Yeah, we want proportion.
So you want the significance level and the 25%?
I want the significance level, and then to say whether the sample data support or not support, we are saying support because we said we're supporting the alternative hypothesis here, so that those parts stay the same. And then support the claim. What was the claim? I literally just copied word for word what the claim was. Yeah. And that's a safe way to be sure you're not missing any piece. Any questions? All right, let's keep going. Let's go to the second one that we made up. Again, I hope these numbers are nice. If they're not, we just keep going through, okay? So, in a random sample of 1,000 pet dog owners, 750 could correctly identify their dog's breed. Using the sample data, construct a 95% confidence interval estimate of the true proportion of pet dog owners who can correctly identify their dog's breed by answering the following questions. So it's going to guide you to do it step by step. Part A, determine the sample proportion. So we know sample proportion, that's p hat equals. You don't have to write this, but if you want to pull it from your formula sheet, we know that's the number of successes over n, right? Which in this case, we're told 750 could identify their dog's breed out of the sample, a random sample of 1,000 people. Plug that into your calculators and you get 0.75. Again, we're rounding to 3 decimal places if needed. Here, it was just a nice 2 decimals, so we just left it as 2 decimals. Part B. Are the conditions for approximate normality met? Again, feel free to reference your formula sheet. I'm looking on the Unit 6 side of the formula sheet because we're still working just with one population. And it even says confidence intervals. Right underneath confidence intervals, it says conditions for approximate normality. Right? The formula is given there. It's given to be n times p hat and n times 1 minus p hat. And for both of these, we need to verify that they're both greater than or equal to 10. So n was 1,000 times p hat, you found to be 0.75. That will give you 750, which that is greater than or equal to 10. Similarly, for the next one, n times 1 minus p hat, that's 1,000 times 1 minus 0.75. And that should give you 250.
We did it the other way.
Mm-hmm.
Is that okay, or can we only do that in later ones?
Which other way?
Where we minus the successes from the.
Oh yeah, that is acceptable as well. So if some of you guys are comfortable with recognizing that the successes was 750, so here, let me write it off to the side. So if instead of writing what I have here on the left, if you instead chose to just do, successes was 750, which is greater than or equal to 10, which means the fails, you take it out of the total, 1,000 minus 750, which is 250, is also greater than or equal to 10. That's acceptable as well. In either case, whichever way you choose to do it, the normality criteria are met, right?
Yeah.
So, yes. Okay.
With, that part, is that right if we write out the words, both are greater than or equal to 10, so normality?
Yep, that is okay too. Part C. Calculate the estimated standard error for a 95% confidence interval. So the key words here, what we're looking for is the estimated standard error. Look to your formula sheet. And again, guys, I know I said it in class, but I want to repeat it here since it's recording. All right. Be sure to print the newest formula sheet, okay, which I posted yesterday, I believe it was, because it has this step and the following step better separated out for you. I mean, if you like the original and you just want to keep it that way, that's fine too, but make sure you're able to distinguish it then, okay? So, on the formula sheet, still under confidence intervals, it says estimated standard error. Estimated standard error, I'm just abbreviating that, but we're given on our formula sheet that it's equal to the square root of p hat times 1 minus p hat all over n. So that's the square root of p hat is 0.75 times 1 minus 0.75 all over n, which we know is 1,000. From here, it's calculator. Let me double check that I did it correctly in my calculator. Alpha y equals, oops, I'm just messing this up. Okay, second square root, fraction, 0.75 times 1 minus 0.75 all over 1,000. If you want to make sure you round correctly, because you're going to use the rounded result moving forward, that's 0.014. Cool.
So wait, when a problem like this says for a 95% confidence interval, we don't do nothing with that?
No, not at this time. It's kind of just a little quick reminder like, hey, we're going to be doing this for 95%, but there's nothing even needed there. What it wanted us to do was to calculate the estimated standard error.
The next part, you do it, because I did it in both on C at first too, and I was
Yeah.
like, what's this then?
Yeah. So part D, find the margin of error. Again, look to your formula sheet. You're not expected to have all these memorized. The margin of error, E, is equal to Z sub C, the critical value, times the estimated standard error. These two pieces you just plug in. Z sub C, the critical value, you get that from your formula sheet. It's on that table, right? It's that table that has 90%, 95%, 99%, and then the Z sub C that correlates to that. Since we're doing 95%, looking at that table, 95% is 1.960. Okay. Times the estimated standard error. The estimated standard error we just got from part C, just from the previous part. So times 0.014. Plug that into your calculators. Oh, I messed up. Rounding to 3 decimal places, I got 0.027. Yeah. Okay. So, part E. Write the 95% confidence interval in interval notation. Again, look to your formula sheet if you need a reminder of what that means. That means an interval notation form. We're going to take p hat minus e, comma, p hat plus e. So substitute those in. P hat we know is 0.75 minus e we just got from the previous step, so that's minus 0.027, comma, and then similarly we take those two values and we add them. So 0.75 plus 0.027. And that should give us, once you subtract those values and add those values, I got 0.723, comma 0.777. Lucky sevens, right? Do you use GoodNotes or do you use something else? You do?
It was only, I think, $3 or something, because I downloaded it.
I might ask you later how like you got these pieces there.
Yeah, I got you.
Okay.
I live.
Okay.
Trade in my iPad because of you. Because of
Girl, I got you.
I have the baby one and
All right, guys. Let's continue to part F. Or any questions here so far? Okay, part F. Explain the confidence interval. Explain what the confidence interval means in the context of the problem. All right, so we are 95% confident that the proportion of pet dog owners. All right, let's go back here. In case you need to remind yourself, right? What are we looking for? We want to know the proportion of pet dog owners who can correctly identify their dog's breed, right? That's the whole point of doing this. So I'm just bringing that down. We are 95% confident that the proportion of pet dog owners who can correctly identify their dog's breed is between, and then we're just going to take our confidence interval, and I'm going to rewrite it in percent form. So it's between 72.3% and 77.7%.
In this one, do you only want us to say proportion? What if we said population proportion? No? Or the proportion of the population?
Let me just remind myself what we're looking at here. Yeah, I'm okay with population proportion. Yeah.
I put according to the random sample, we are 95% confident, and then I put the number first and then of dog owners correctly.
Yeah.
That's okay?
Yeah, we have a slight variation. Yeah, both those examples were good. Yeah. Any other questions? Okay. I still see some people writing, so I'll leave this here for a second. I'll see you next Monday maybe or some other time. But I'll post this stuff online.
Unfortunately, I work double on Monday, but I will look online.
Okay. Bye. Okay, so I'm curious. I know that in class, the majority of people were at least able to start this question, maybe finish it. How many? This next page is blank. How many of you guys were able to finish this one? The third one. Okay. I'd like you guys to give it a try first. Okay? Give it your best shot. Have your formula sheet. Sure, you could work with people at your table too if you want, or people around you, but I do want you to give it a try first. How much time should I give you guys? Like,
5, 10 minutes.
I was thinking, yeah, like 10 minutes. Okay, I'm gonna set my timer for 10 minutes. For those of you who are watching this recording at home later on, just like skip 10 minutes, I guess. Because I don't think I could pause it. So, okay, 10 minutes. Give it your best shot. Bless you. Bless you.
Hypothesis test, there are no actual values in the alternative, you're just comparing P1 and P2. But there's no numbers in it when we're writing the null.
Okay, okay.
What? There's 6574.
Yes.
Okay.
Why did you put it, P1? How did you?
So I think once you start there, that will be
Oh wait, sorry, I just saw that and I thought you didn't have a copy. Well, there's an extra.
not P hat. But it's okay. That's the point of it, I guess.
Well, I'm like super lost on the null and the alternative. Like,
So then the null will always start out as the
See, that's kind of
All of a
70,
sudden.
or simple,
In this case, since they're working with
So
two
32 divided by
populations,
7.
it's automatically P1 equals P2. That's just how you start with the null. And then when the first problem we did, notice it was also P equals, and just in this case, instead of it equaling another P, it equals the exact number of 0.25. It's still equal. And then each sub A, you're gonna be comparing P1 and P2, but using an inequality sign. Exactly. Okay. I had the second part, just look at the first part. It says right here, that's why I said this is an alternative, because it says right here, that the proportion of one to a percent is less than the proportion of none. Less than, so that's what it means, so that's our alternative.
so what equals what if you want total population? And then P1, I mean, P1 is.
Is it not on there? It's one. Is less than P2. Because that's what we're claiming. Yes.
Because I know it's.
Yeah.
And this is our actual value.
The sample values.
It's full proportions, so basically
Did you hear this?
just like
Yeah,
X1
so
plus
I'm
X2.
I think there's some kind of division that's going on.
Should be on the second page,
Why do you look at my yellow one? Because I'm almost
yeah. Yes.
4 years. Look at
Dude, he's pretty smart.
So portion is 65.
X is basically X, the way I see it is like, so it's like you gather around a sample of 70% of women and you find 32 which have 70, so X would be 32, and then the next one, X2 is the result, you know, so I see.
Correct, for the first population. You wanna write success? Yeah, that's fine.
So X is a success, X is success.
Yes.
Basically,
For each population.
Yeah.
78 or 70?
I just feel like
Oh, 4 minutes left, guys. 4 minutes.
I just don't remember what to do for this.
So our P1 is our winning.
So you need to find the sample proportion for the first
Oh, so I
population.
did.
Yep, you were on the right track. Yeah,
Okay.
and then you just subtract them.
A random sample of 7 for winning, that's what we're paying. 92 haven't paid, that's a success. And then for the men,
For those, it was the percentages.
78 men, 38.
Or did you have to divide them to?
So you did the P sub 1, like 38 over 70.
Oh, okay.
And then P sub 2.
You divide and then divide? That's what it should be. Why do we
For
switch
the,
it back?
yeah.
And then you subtract that.
Isn't it just taking the?
So,
Oh, that's the entire.
exactly, yeah,
Okay.
versus this is breaking it
Okay.
down, yeah.
Now I get it, 'cause I was like, why would we do that?
Yeah, they jumped ahead to the.
Do it like that, or can I add these and add these and everybody?
That's what I add them.
Okay.
But you could do all of them go if you want.
Yeah.
Wait, I think I did this wrong.
Hold on, maybe guys.
Yeah, you ran
I
across
got
green.
90. I don't think this is right. Wait, let me see. So when we, after we do our sample version for each one,
Mhm.
then we subtract it?
Yeah.
Okay, so
That's exactly it.
That's what I got.
it's because they're kind of making it
0.1.
Yeah, it's okay to get this one.
Putting it in the calculator.
Whatever P1 is always first, it's always P1 minus P2. Or P1 half.
What happens if you do it the other way?
They'll give you the wrong answer.
It gives you the wrong answer?
Yeah.
Okay, so you gotta make sure you like, you can put it back.
Yeah.
Okay. I was curious, I never did it.
I like
though.
your sushi.
I think
Ramen.
got like $10 at Marshall.
What?
Yeah,
I love ramen too.
yeah, ramen's so good. I only had it once since I've been here, but I think it's pretty good.
There's a really good.
I like pho. Pho's really good.
I like ramen better.
Really?
There's a really good ramen place in Huntington Beach by Target. Wow. Where's that?
I went to Katsu Ramen.
Yeah.
Oh, that's pretty good.
And then there's a really good fun spot of cherry.
In Long Beach. We need to make a long trip.
Yeah. It's like last day of the semester.
Yeah.
Wait, Professor, quick
Yeah.
question. So, up here on this question, it says rounds 3 decimal places. Does that like include like every single problem?
Yeah.
Round? Okay.
Yeah.
So, okay.
If needed, because sometimes you'll get just a nice 2 decimals, which
Yeah.
is just leave us 2. But otherwise, yeah, every.
Oh man, I think I might have messed up. 'Cause I've been like going 3 decimals.
Yeah, no, 3.
Okay.
Yeah, most likely they're all gonna be 3.
I'm gonna do the little picture.
Find female.
So I do the little lasso, and then I like to gather the.
That's what the lasso is
And then
for.
you tap it, and then I take a screenshot, copy it, and then I go to my thing, and then paste it. And I can also like press on it, you can crop it, or freehand, like if you only want like a peak, like my circle, it looks like that.
Okay, I'm gonna practice that with this because there's not enough space. So I want
could
I
gather
want to
and make it
lasso
smaller.
it. Yeah, just for the piece I need. Or okay, I'll practice that.
Yeah.
Okay, so that's 10 minutes. Where are you guys at so far?
Amongst C.
D, C,
D, C.
Okay, so how about like 5 more minutes?
Yes.
Okay. So for those of you who are watching this recording online, we are working on this for another 5 minutes. I don't know. We'll
I
see
don't
how
wanna keep going until I know if I got the full proportion right.
Yeah, right. Did I use the wrong?
Correct.
Okay, so. Because I used the wrong.
Take another
You
look
got
at it.
-6 point, or -0.675.
Yeah, your X is